All right, this is going to be the molecular weight of a compound by freezing point depression measurements lab. And what we're going to be doing is we're going to put in benzophenone. That's going to be our solvent. It's solid, and we're going to put it into a water bath. We're going to heat that up with a Bunsen burner. And then we're going to melt the benzophenone and let it freeze again, and we're going to see what its freezing point is. And then we're going to add to that benzophenone an unknown that is going to be melted with it, and then that mixture is going to be allowed to cool, and then it's going to freeze at a lower temperature. So we have those two temperatures. That's going to be our delta T, and with our freezing point depression equation, we're going to be able to find the molecular weight of that unknown. All right, so let's get started. Okay, I'm going to weigh out our solvent, which is benzophenone. I'm going to need about 10 grams of this. It doesn't have to be exactly 10. We just have to know what it is when we put it into the test tube. Overshot it a little bit, that's fine, considering I'm doing this all one-handed and holding a camera. So 10.433 grams of benzophenone will be used. All right, let's add in the benzophenone into the test tube. And one thing, yeah, I think it is. It looks like the benzophenone should be below the water level. Yep. Just make sure everything gets heated up thoroughly. I'll bring this down here and turn on the gas. Oh, okay. See how tall this is? Yep, that's pretty good. And we want it to heat pretty fast. All we're doing is boiling water. Not even boiling water. We just want to get it to the point where the benzophenone will melt. Let me get rid of... There we go. You can see it a bit better. All right, this is going to take a little time, so we're going to let this sit, and if it boils, it boils. It doesn't really matter, but the benzophenone should melt long before then. So as soon as the benzophenone turns into a liquid, I'm going to take the test tube, go a bit higher. I'm going to raise this up and get it out of the water, and then I'm going to add in the thermometer so that we can see what its temperature is when it freezes. All right, we're about 5 minutes in. I put a whiteboard behind it. I noticed that my camera was focusing on the desk behind the reaction vessel rather than on the reaction. So see that we're up to 65 degrees, and you can see that the benzophenone, which was about twice as high before, it's melting. And when it's completely melted away, that's when I will draw the test tube out of the water to let it cool faster, and then I'll put the test tube right into the liquid. Okay, so this could take a couple more minutes, so we'll jump ahead. All right, so we're well below the freezing point of the benzophenone. Sometimes the crystals just refuse to form. They need to form on an imperfection in the glass, someplace to start the crystal process. So when that doesn't happen, it gets into this metastable state. It's about 10 degrees cooler than the freezing point should be. But the thing is, once it starts to freeze, it will go right, it's a phase transition, so it'll go right back to that freezing point. Now I took the thermometer out. Oh, there we go. To cool it, and that shock sometimes, there we go. It'll start the process. So we're gonna watch the crystal swarm for a bit. It's kind of neat. And then I'll show you the temperature. And right now it was around 30 degrees, and it's rising back up to right where it should be because it's a phase transition, so it has to. There's no concern that it had dropped so low in temperature. When it finally decided to form a solid, the temperature went right back up, right where it would go for the freezing point. So let me see if I can't. I can't quite reach it. All right, I'm gonna take this out. And now it's in the phase transition, so it's locked in, and it says it's around 46.5. Okay, I'm going to weigh out the unknown, and I didn't say this in the beginning, but I'm going to do just one run, one experiment, and show all the data. But then the second experiment, I'm just going to list the data at the end. Okay, so all right, and so here's our unknown. It's being a little sticky. Okay. And we got might as well use it all. Can. Okay, 1.947 grams of unknown. So now I have to change that solid back into a liquid so that I can open up or take this out. Everything's really trapped in there inside of the crystals. So we'll liquefy the benzophenone, and then when it's liquid, I'm going to add in this unknown to the test tube, and then we'll do the process again. We're going to melt the unknown and with the benzophenone, and then take it out to let it cool. All right, it's melted enough that I can take the thermometer out. And it's back, and I'm going to put the unknown in. And then put the stir bar, or the stirring wire in. Oh, it is hot, hot, hot. Okay. And oops, we'll let that melt. Okay, I paused there. Took about 2 minutes of the stirring to get it to break up and melt. So we jumped ahead a bit, but it's ready to go now. I shut off the heat, and so I'm going to raise this up as I did before and let it cool, and then we'll see what the temperature of the mixture is, so the freezing point of the mixture is, once it turns back into a solid. So here's the mixture. It was about 10 degrees lower than it seemed it should be. You know, we can't be sure because the mixture is going to freeze at a lower temperature than the pure benzophenone, but it does seem low. So I'm trying that trick again, where I'm cooled the thermometer to room temperature and see if kind of looks like something's happening. Maybe not. Okay, there we go. It's happening very slowly this time. Very, very slowly, but you can see that it is crystallizing. And I'll show the temperature here in a second, but it's still rising. So the crystals are forming very slowly. The temperature is slowly rising. Interesting, I haven't seen it do this before. Usually it crystallizes very quickly. But it does look like the temperature has finally evened out. It's no longer rising, so we'll take a look here. Of course, it has to be right there, but that is about 32.5. And I'll double check that once I can move the stopper, but I believe that's what it is, and I'll list that in at the end.